Okay, so today we are looking at 6.4. We are looking at solving systems using elimination part 2, just like we talked about yesterday. So basically elimination, when I'm looking at elimination, I'm trying to eliminate one of the variables, either x or y. Now they could be different variables, but I'm trying to eliminate one of them. So what we did yesterday is I looked at it and I said, okay, when I add these two equations, how do I eliminate one of the variables? So when I add two things together, one of them has to be a negative, one of them has to be a positive of the same numbers, because then it cancels out to give me 0 when I add them together. You have to add them together. So yesterday we looked at things that were already, equations that were already set up nicely for me, where I already had a positive and a negative of the same coefficient, which is the number in front of the variable, positive and negative of the same number, so I could add and cancel, or I had the same number, so I multiply one of the equations through with a -1 so that it canceled out. Today we're going to look at a little different. Okay, we are going to do the same big idea. We're still going to do elimination, but now we have to do something a little different to get it set up to be able to do it. So as I look at example 1, first thing you want to ask yourself, are there any variables that will cancel out if I add the equations? So if I look at this right now the way it is, and I try to add them, will any variable cancel out like we did yesterday? Well, if I look at it, I have 4g and 2g, so that would be 6g. I have 8h plus 2h, which is 10h, so no. None of the variables are going to cancel. So no. Next question, like we talked about yesterday, will multiplying one of the equations by -1 allow a variable to drop out? Well, no, because you have to have the same number, same coefficient, in order to multiply by negative, so that one will cancel out. So even if I multiply one of the equations by -1, I still am not going to have the same number opposite sign. So it still will not cancel when I add them. So now the next question is, can I multiply by a number to make a variable drop out? So as I look at my equations, I want to look and say, okay, can I multiply one of the variables, one of the equations, by a number that will then cause, when I add them, for something to drop out? So this is how you do this. You look at your smallest numbers, look at your variables, and see what will happen. This is a 4g, this is a 2g. So I need to get same number, opposite sign. So is there any way I can make this 2 into a -4? Yes, by multiplying by -2. You can also look at it this way with the h. Is there any way I can make this 2h a -8 by multiplying? Yes, I can multiply by -4. So you can either choose to cancel out the g or the h's in this case. I'm going to choose to cancel out the g's. Since I have a positive 4g on top, I need a -4g on the bottom. So I'm going to take my bottom equation and multiply everything by -2. So that's -4g minus 4h equals 8. I multiply everything by a -2. So distribute the -2, -4g minus 4h equals a positive 8. My top equation I did nothing with. It stays the same. If I look at this now I notice, like we did yesterday, I have same number, opposite sign. 4g and a -4g. So if I add these, you have to add the two equations together. If I add these, I notice that 4g plus a -4g is 0, so it cancels. And you have to add the rest. 8h plus a -4h is a positive 4h, equals 16 plus 8 is 32. So I have 4h equals 32, so now it looks just like we did yesterday. 4h equals 32, divide by 4, h is equal to 8. So if h is 8, we need to find g, because I need an ordered pair. So we're going to plug it back into any one of these equations to find 8, or find g. It doesn't matter if you use the original equation, or the one after I multiply by -2, or the top equation. I'm just going to use the original bottom equation. So I have 2g plus 2 times 8, because that's where I found h to be. So instead of h, I substitute an 8, equals 16, or equals, -4. Make sure you use the right equation. I'm using the bottom one. It doesn't matter, but you have to make sure you plug it in consistently. 2g plus 16 equals negative 4. Subtract 16, subtract 16. 2g equals negative 20. Divide by 2. G is negative 10. So I have to find both of the variables. Now to write this as an ordered pair, it goes in alphabetical order. G, comma, H. So negative 10, comma, 8. So once you multiply one of the equations, it's just like we did yesterday. Okay, let's look at another example. Let's look at example 2. So you need to ask yourself, okay, this is set up nicely for elimination because they're both in standard form. So since they're both in standard form, they're set up nicely for elimination. So I need to ask myself, okay, if I multiply, or if I add right now, will anything cancel? No, because none of my coefficients are the same number opposite sign. So when I say, will multiplying by a negative get it? Well, no, because none of these coefficients are the same exact number. So that's not going to help me. So then I just say, okay, what will help me if I multiply one of the equations by something? Look at your smaller coefficients. Can I make 2x into a negative 4x? Yes, I can multiply by a negative 2. I can also look at my y's. What can I multiply y by to get a positive 3y? I want a positive 3 because I have a negative 3 on top. So I'm going to go ahead and choose to cancel out the y's. You could choose to cancel out the x's and you would get the same answers. But I'm going to choose to cancel out the y's. So I'm going to take my bottom equation and multiply by a positive 3 because that will give me a positive 3y as my coefficient in the bottom equation. So then when I add, my y's will cancel. So go ahead and rewrite your equations. My top equation stays the same. 4x minus 3y equals 1. My bottom equation, I'm multiplying everything by 3. So 6x plus 3y equals 9. I notice I have same number, opposite coefficient. So now to cancel, I have to add these equations. You are adding the two equations together. 4x plus 6x is 10x. Negative 3y plus 3y is 0, so that is gone. And that is equal to 10. Solve that equation. Divide by 10. X is 1. And I need an ordered pair. Solving a system, I always need x and y, both points. So if I know x is x is 1, to find the y value, it doesn't matter which equation. I'm going to choose the original bottom one because it looks the easiest. So 2 times 1, plug 1 in where x is, plus y equals 3. 2 times 1 is 2, plus y is 3. Subtract 2, y is equal to 1. So my ordered pair is 1, 1. So if I would graph both of these lines, these two lines will intersect at the point 1, 1. Okay, the nice thing about a video is you can pause it if you need to write these down at any time. I will be checking again to make sure you're writing these notes down like I did last week, or earlier this week. So if I look at example 3, first thing I notice is I have this plus 6 over here, so I need to get it in standard form, so I'm going to subtract 6. So now I have 4x minus 5y equals 8. So you want to make sure it's in standard form first, so subtract the 6. Now I look at it and I say, okay, well, let's try to, if I add these two equations, first of all, elimination is the best choice because they're in standard form. Neither equation is x equals or y equals. If I add right now, will anything cancel? No, because none of my coefficients are same number, opposite signs. So neither x or y's will cancel. If I multiply one of these equations by a negative 1, will it help? Well, not really because I don't have the same number here. So I have to have the same number on the x or the same number on the y. Okay? So as I look at this, we need to decide, okay, what can I multiply one of these equations by to get something that will cancel out? Look at your smallest coefficients first. If I look at my x's, can I multiply 2 by something to get a negative 4? I need to get the opposite. This is a positive 4 on the bottom. I need a negative 4 on top. 2 times what gives me negative 4? Negative 2. But if I look at my y's, can I multiply negative 4 by something to get a positive 5? You could do a fraction. Don't do fractions. So instead of canceling out y's, we're going to cancel out x's. So we're going to take my top equation. I have a positive 4x in the bottom, so I'm going to multiply my top equation by negative 2. And that will give me negative 4x. I distribute the negative 2. Negative 4x plus 8y equals negative 26. And then your bottom equation, 4x minus 5y equals 8. So you have to decide what can I multiply one of the equations by to cancel out when I add, to get the same number, opposite sign, coefficient. Now I notice I have a negative 4x and a positive 4x, so if I add these together, if I add these two equations together, I notice the x's will cancel. Negative 4 plus 4 is 0, so those are gone. 8 plus a negative 5 is positive 3y. And then negative 26 plus 8 is negative 18. Now I have a simple equation. Divide by 3, y is negative 6. Solving a system of equations, I always need x and y. So if y is negative 6, plug it into an equation to find x. It doesn't matter. Let's just use this one. So 4x minus 5 times negative 6 equals 8. So I'm plugging negative 6 in where y is. 4x, negative 5 times negative 6 is 30, so plus 30 equals 8. Minus 30, minus 30. 4x equals negative 22. Okay, if I go ahead and divide by 4, make sure I didn't do anything wrong. Let me double check. Negative 2. I plug it back in for y. Nope, it might just come out as a fraction. Divide by 4. So x equals negative 22 divided by 4. Sometimes you may get a fraction, which is fine, or you can turn it into a decimal. Negative 22 divided by 4 is negative 5.25. No, 5.5. Negative 5.5. So my ordered pair is negative 5.5, negative 6. Sometimes you may get a decimal. You just go back and double check real quick. Okay, let's look at example 4. As I look at example 4, go ahead and cross out the two equations I have and put these two equations. So take a second real quick, pause this, and change the two equations I had on there to 6a plus 2b equals 2 and 4a plus 3b equals 8. Now as I look at this, we have to check, okay? Do I have same number, opposite coefficient? No and no. So if I add these right now, nothing will cancel. If I multiply by negative 1, so do I have the same coefficient for any of these? 6 and 4, 2 and 3, no. So then I look again and I say, let's look at my smaller coefficients and let's see, can I get something, can I get same number, opposite sign by multiplying? So as I look at this, we have 4 and 6. So will 4 times something give me a negative 6? Do not think about fractions. Will 4 times something give me a negative 6? No. So look at the b's. Will 2 times something give me a negative 3? No. So now I have to ask myself, okay, how do I go from here? So what we need to do is we are going to have to multiply both of these equations by something. So what I want to look at is I want to look at, okay, it doesn't matter. We can either choose A or B. I'm going to choose B now because the numbers are a little smaller. So we're going to look at my coefficients, 2 and 3. What is the smallest number that 2 and 3 can multiply into? So what is the smallest number that 2 and 3 can multiply into? If it's hard to think, you can always just multiply them together. It may not be the smallest number, but it will work. So the smallest number that 2 and 3 multiply into is 6. So I need to make one of these a negative 6. So I'm going to take my top equation and multiply by a negative 3. That will give me a negative 6b. And then my bottom equation, I already have a 3b, so I need to multiply it by 2. So I'm multiplying both equations to get a same number, opposite sign coefficient, so it will cancel when I add them. So I'm going to get a negative 6b on top by multiplying by a negative 3. I'm going to get a positive 6b on the bottom when I multiply by 2. So you have to pick one of the coefficients, one of the variables, and decide what I need to multiply both equations by. Now make sure you distribute to everything. I'm going to take negative 3 and multiply it to every term in the top. That will be negative 18a minus 6b equals negative 6 when I multiply negative 3 through the whole top. And then my bottom equation I multiply by 2. So 8a plus 6b equals 16. So I multiply everything by 2. Now I need to figure out, now I notice I have same number opposite sign coefficients, negative 6b and positive 6b. So now we do it just like we did yesterday. If I add these two equations, the b's will cancel. Negative 18a plus 8a, negative 10a, negative 6 plus 6 is 0, equals negative 6 plus 16 is 10. Now I have an easy equation. Divide by negative 10, a is negative 1. Once you get your equation like this, it's just like we did yesterday. If a is negative 1, I need to find b. It doesn't matter which equation. I'm going to choose the top original one. Doesn't matter if you choose the one after you multiply through the negative 3 and 2 or before. So I'm going to choose the top original. So 6 times a, which we just found to be negative 1, plus 2b equals 2. Solve this for b. Negative 6 plus 2b equals 2. Add 6, 2b equals 8. Divide by 2, b equals 4. So my ordered pair, put in alphabetical order, negative 1, 4. So if I would graph these two lines, negative 1, 4 is the point where they cross. Okay, last one. Okay, elimination would be the best choice because they're in standard form. So I look at this and I say, if I add now, will anything cancel? 5 and 2, negative 3 and 5, no. If I multiply by negative 1, well, none of the coefficients are the same, so no, nothing will cancel. So now let's look at my small coefficients on each one. Can I multiply 2 by something to get a negative 5? So if I'm looking at my x's, can I multiply 2 by something to get a negative 5? No. And then I look at my y's. Can I multiply negative 3 by something to get a positive 5? No. So now I'm going to have to look and see what can I multiply both of them by. Now it doesn't matter if you choose to eliminate my x's or y's. Just a little something that might be a little easier is if I look at my y's, I already have a negative and positive. So that's going to have to prevent me from multiplying by a negative number. So the y's might be a little easier. So let's look at my y's. I already have a negative and a positive. So what's the smallest number that 3 and 15 multiply into? Sorry, 3 and 5 multiply into, and the answer is 15. So I'm going to work to make each one of these equations have one of them will have a negative 15y and the other one will have a positive 15y. If I look at my top equation, negative 3 times what will give me a negative 15y? That is a 5. So I'm going to take my top equation, multiply everything by 5. That will give me a negative 15y. My bottom equation, I already have a 5y. 5y times what gives me 15y, and that is 3. So I multiply everything by 3. So if I distribute through a 5 at top, 5 times 5x is 25x minus 15y, and then 5 times 6 is 30. The bottom equation, multiply the 3 through. 3 times 2x is 6x, 3 times 5y is 15y, and then 3 times negative 10 is negative 30. Now I have an equation just like we did yesterday. I noticed on the y, I have a positive and a negative 15. So when I add these two equations together, you have to add them together. The y's will cancel. 25x plus 6x, 31x. Negative 15 plus 15 is 0, so that's gone. And then negative 30 plus a negative 30 is also 0. So don't freak out if you get a 0. You just get a 0. Divide by 31. 0 divided by anything, 0 divided by 31 is 0. So x is 0. I need to know my point. So if x is 0, plug it into any of these equations. I'm going to use the, I don't know, it doesn't matter, bottom one. So 2 times x, which is 0, plus 5y equals negative 10. 2 times 0 is gone. 5y equals negative 10. Divide by 5, y equals negative 2. So my ordered pair is 0, negative 2. Okay, so hopefully that helps. So what you're going to have for homework is a little different. So what you're going to have for homework is you are going to have 4 questions you need to get done before e-learning is done. So your assignment is 359, 1 through 4, and then 7 through 16. Okay, so 1 through 4, 7 through 16. So what you need to do, 1 through 4 need to be done on a separate sheet of paper, and these need to be turned in to either Mrs. Glassford or Mrs. Foster, turned in by end of e-learning. So you're going to do those on 2 separate sheets of paper. So 1 through 4, you're going to start the assignment, you're going to do 1 through 4. That's going to be done on 1 sheet of paper. You're going to turn 1 through 4 on a separate sheet of paper into Mrs. Glassford or Mrs. Foster by the end of e-learning. 7 through 16 you will do after you turn in 1 through 4. You're going to do 7 through 16 on a separate sheet of paper, and that will be the rest of your homework, which will be due Tuesday like normal. So 1 through 4, do on a separate sheet of paper, turn it into Mrs. Glassford when you get 1 through 4 done, and I'll look over it. 7 through 6 is the rest of your assignment. You can work on it when you get 1 through 4 done and turned in. 7 through 6 will be due Tuesday, and I'll go over questions Monday. So I want to make sure that you have this all set. Also, I believe we may be doing NWEA testing on Monday, so make sure you bring your Chromebook with you. Okay? Have a good weekend. If you have questions, I'll be here Monday before school, or I can stay for tutoring. So let me know.